Hello and welcome to Unlocking the Potential of Monitoring-Based Commissioning. This is the second in a series of webinars we're hosting, which will provide a forum to come together, share challenges and learnings, and help to evolve energy efficiency programs. I'm Karen Healy, your moderator and web organizer. Today's panelists are Dan Reese, Associate Director of PECI, Dave Moser, Senior Engineer at PECI, and Robert Austin, Western Region Operations Manager for Eaton Energy Solutions. Dan oversees PECI's portfolio of existing building commissioning, as well as our existing building commissioning consulting, design, and research projects. Dave provides engineering services for a diverse range of projects and programs at PECI, all centered on building energy efficiency. And Robert is responsible for the overall management and execution of all energy commissioning and retro commissioning projects in his region. We'll now begin our presentation. Take it away, Dan.
Good morning, everybody, and thanks for joining. Just a quick look at the agenda here. We're going to start with an overview of monitoring-based commissioning, just so we're all kind of starting from the same page. We'll look at two different types of case studies in the realm of monitoring-based commissioning. We'll share some ideas around choosing a monitoring approach, and then we'll close with resources and Q&A. And by the end of this webinar, the goal is to enable you all to be able to talk to the following points. First one being able to state the differences and advantages of monitoring-based commissioning compared to a typical commissioning project. Second is to be able to list the main activities included in the monitoring phase. Thirdly, be able to describe two examples of energy and system monitoring approaches, one using utility interval meter data and the other using the building automation system. And finally, to be able to discuss the considerations related to selecting a monitoring approach. And as Karen mentioned, we'll be conducting several live polling questions, and here's our first. The question is, what is your role in implementing an MBCX program? And you'll see the question come up in the sidebar to your right. If you would just answer that briefly, we'll take a minute to allow the answers to come in. And while we're waiting, I'll just give a brief overview of PECI so you know who you're hearing from here. We are an energy efficiency nonprofit that's been in the business for about 30 years. We've been working on commissioning for more than 25 years and have a long history of innovation and program design and development in this area. And our work focuses on capturing operational savings through flexible platforms and strong outreach and training. So we have a short look at who we have on the line here. It looks like quite a few fall into category C there, engineering service providers, and also some folks from utilities and building owners. So with that, we'll move on to the start of the presentation. And I'll hand it over to Dave Moser.
Okay. Thanks, Dan. So first, as Dan mentioned, we're going to give an overview of MBCX, or monitoring-based commissioning, just so that we're on a level playing field in terms of what we're talking about here in this webinar. First is the define existing building commissioning, and these are definitions from the Building Commissioning Association. Existing building commissioning is a little more well-known than monitoring-based commissioning, and EBCx is a systematic process for investigating, analyzing, and optimizing the performance of building systems through the identification and implementation of low and no-cost and capital-intensive facility improvement measures and ensuring their continued performance. Whereas MBCX is a process variation of EBCx, where it supplements that process by including ongoing monitoring through either remote energy system metering or trend log capability to identify inefficiencies in system operations, facilitate diagnostics, document energy savings, and then really ensure persistence of savings through this ongoing recommissioning. So MBCX is, in summary, it's a process variation of EBCx that includes more of a ongoing monitoring component. So the existing building commissioning process, these are phases that are included in the EPA's guide called a retrocommissioning guide for building owners, where it shows the typical phases, starting with the planning phase, moving into investigation, and implementing the improvements, and then the handoff phase, which is developing persistence strategies and conducting training, and then ongoing operations. Where MBCX typically includes more emphasis on the ongoing operations phase than EBCX. And the monitoring component occurs mostly during this ongoing operations phase, although monitoring systems can be evaluated during the planning phase, and monitoring can begin as early as the investigation phase. So if it's an MBCX project, you might be starting MBCX activities earlier in the project than just ongoing operations. As I mentioned, the graphic on this slide is from the EPA guide on retrocommissioning, which was developed by PECI. And we will include this guide in follow-up communications to you after the webinar. So why bother with monitoring-based commissioning? Well, one main reason to add a monitoring component to the EBCX process is to protect the investment. Monitoring can help extend the effective useful life, or EUL, of implemented measures. The chart that you're seeing on this slide is from a recent impact evaluation of existing building commissioning utility programs in California. On the x-axis is years since installation of the measure, and the y-axis is the percentage of those measures that have failed. And this study basically looked at measures that have been installed in the last 3 years. That's where you see the 3 red dots. And they extrapolated that line out to find that the average EUL, or effective useful life, without monitoring is 8 years. So since monitoring-based commissioning includes more emphasis on maintaining the persistence of those measures, the EULs should be longer with MBCX. In fact, there's some MBCX utility programs that cite an EUL of 15 years, which is the brown line that's shown on this chart. So something to keep in mind is that the EUL for MBCX measures is typically longer than just a regular EBCX project. This chart here shows how energy usage might vary over time if a building performs periodic commissioning. So you can see that on the first existing building commissioning effort, the usage drops, but then it starts to creep back up, basically because many EBCX measures are behavioral or operational in nature, and it's relatively easy for them to go out of persistence. So the blue shaded area in that chart represents the energy savings. So if we're able to maintain the persistence of those measures, that's shown in the light yellow area in the chart. So your savings would remain for a longer period of time. If you're able to enhance the measures that were implemented, then the savings will actually become deeper. So that means go deeper with the savings on measures that were already implemented. And then finally, MBCX can include a process of continually identifying and implementing new measures, and that could reduce the energy usage even further. So you can see that there's typically greater savings over a building's lifetime with monitoring-based commissioning than with just periodic existing building commissioning. So some utilities across North America have offered MBCX programs for a number of years with a focus on energy savings. It's important to note that MBCX can also be used to monitor non-energy aspects of building performance, such as indoor air quality. And once you get into the monitoring phase, mainly during the ongoing operations phase, it's really a continual process. So the first step is shown on the top of this chart here is to collect the performance data, which could include energy data and equipment performance data. The next step, step 2, would be to detect the performance issues through analyzing that data that was just collected. Third step would be to meet with the facility staff to diagnose the issues and identify solutions. Also, during that third step, you can report out on persistence of previously implemented measures. That's really one of the advantages of monitoring-based commissioning, is to maintain persistence. And then finally, the fourth step is to fix those issues and verify the results. So when we talk about MBCX, it's more than just data acquisition. It's really part of an overall process that includes analysis of the data and, most importantly, taking corrective action based on that monitored data. The graphic on this slide is from the California Energy Commission's Building Performance Tracking Handbook, which was prepared by PECI. And a copy of this handbook, which is available for free online, a copy of that handbook will also be included in follow-up communications. Okay, there are two general categories of monitoring systems, and these are shown as the vertical columns on this graphic. You have energy tracking, which is on the left side, and then system tracking on the right. Energy tracking monitors the energy usage of either an entire building or specific systems to identify performance anomalies and maintain performance. And with energy tracking, it can use either the main building energy meter or sub-meters installed throughout the building. System tracking would monitor the performance of specific systems in the building, such as HVAC and lighting systems. They can use existing control systems, such as the building automation system, or they can use additional software, such as fault detection and diagnostic tools. This graphic also shows the three types of tracking systems under each of those two categories, and those are what are shown as the rows on this chart, where you have advanced tools, such as advanced energy information systems and fault detection and diagnostic tools shown on the top. It's automated alerts, all the way down to basic tools, such as Energy Star's Portfolio Manager and just using the building automation system for troubleshooting. So Robert Austin from Eaton is going to provide a case study of an energy tracking system here in a little bit, and then I'm going to provide an example of a system tracking system. And the graphic on this slide is also from the Building Performance Tracking Handbook, which will be sent out to webinar attendees after the webinar. And the handbook has details on each of these 6 tracking methods that are shown here. So there's a softer side of MBCX. There's a pretty strong people component. So to further assure those persistence of benefits, MBCX programs should also include such aspects like operator training, which can be both informal and formal. It's important to include the building operators on the MBCX team because they really have a feel for how the building is performing and what opportunities are really realistic for implementation. It's also important to update any building documentation, such as building plans, controls drawings, control sequences, O&M manuals, etc., based on the implemented measures. It could also include developing new documentation that would help the operators maintain performance of those systems. And finally, MBCX can include simple strategies for maintaining persistence. It doesn't have to involve gathering and analyzing data. So for instance, you could include persistence-related activities such as visual checks of equipment performance in the facility's existing preventive maintenance system. That's something that we found to be effective in maintaining persistence, and it's something that typically resonates with the operators. Basically just beef up a system that they already have in order to maintain persistence.
It's time for the polling question number 2 here. And the question is, where are you in the process of implementing MBCX projects? And again, you'll see the answers on your right. Please select one. And while we take a minute for this polling question, I wanted to describe a little bit about Eaton Energy Solutions, with Robert Austin from Eaton presenting next in our webinar. Eaton Energy Solutions has over 4 decades of energy engineering and consulting services behind them. They've completed hundreds of projects in virtually every type of building and environment. They also have a full range of energy solutions that include energy management and planning, energy audit solutions, new building and existing building commissioning, energy modeling, and turnkey energy project solutions. And I'll also take a moment to remind you to submit questions on the Q&A on the panel on the right-hand side of your screen. Looks like we're already starting to get a few. And we will be getting to those at the end of the presentation. Now, as the answers are coming in on this polling question, we're seeing that a lot of folks are in the learning stages of MBCX, but we do have a few folks on the line who have some experience implementing projects. And with that, we'll move on to the next part of our presentation. And I'll hand it off to Robert.
Thanks, Dan. I appreciate it. As David mentioned in a prior slide, there's basically two approaches that you can take to monitoring-based commissioning. One involves energy tracking and the other involves system tracking. What we're going to look at in this particular case study is focused in on the energy tracking approach for monitoring-based commissioning through a case study that's been done at multiple universities throughout the state of California. For those of you that are located elsewhere and aren't aware of this program, basically the way it works is the University of California and California State Systems have partnered with the investor-owned utility companies in California, such as PG&E, Southern California Edison, and San Diego Gas and Electric, and have partnered together to implement monitoring-based commissioning on their campuses throughout the state. We've had the privilege of participating with 3 of these campuses with about 17 facilities that range from lab research buildings to office buildings to classroom buildings and participate in this program to help drive it as a solution provider. The focus of the program, in addition to implementing existing building commissioning practices, is also to incorporate monitoring approaches into the project through energy information systems and interval utility data tracking. So the way it works is the program implements existing building commissioning, but it adds and it augments that process with a monitoring and metering approach that uses interval utility data and interval chill water and steam data for most of these campuses, since they have district utility plants, to augment the process by creating baseline performance models through these energy information systems and comparing them to the post-implementation state at the end of the project for a couple of purposes. One is because the investor-owned utility is funding the program. They want to have a means to validate the energy savings, and so this approach allows them a mechanism for doing that. But the other purpose of it is to implement persistence strategies as part of these projects as a particular focus of the program as well. So with these projects that we participated in, the typical savings and cost range that we've seen in the various facilities have been anywhere from 5% on the low end all the way up to 20% on the high end. There's quite a range of costs associated with the projects as well, and the variability here between $1 and $3 a square foot really has to do with not so much a variability in the monitoring-based commissioning process itself, but a variability of the technology applications that are needed to implement the process. So a big cost component in some cases is the interval metering that needs to be installed as part of the project if the facility doesn't already have it available, and that adds a fair amount of cost to the project as well. So that's one of the reasons for the higher range of costs. The typical payback ranges have been in the 3 to 5 year range. However, because it's a partnership program with the utilities have typically bought down through incentives most of the projects that we've been involved in to about a 2-year payback or better. So the process doesn't deviate a whole lot from the existing building commissioning process, with the exception of the first portion that really focuses in on the metering. So the first step in one of these projects is to go in and assess the existing metering that's available and all the energy and utilities that are coming into the building, be it electrical energy, natural gas energy, or chill water or steam energy. If these utilities aren't individually metered, then it makes the process challenging to implement. So the first step is to ensure that the 15-minute interval data capable metering is installed in these facilities, and if it's not, the installation and design of that metering, as well as the system or software that's going to be used to capture that data over time and store it, is implemented as part of the program. So the way this works from a process standpoint is the first step is obviously installing the metering. An important part of these programs is to capture a baseline for these facilities with the interval utility data. So that means that before the project can really get underway, the metering has to be installed so that a 3-month period of baseline data can be collected. Once that metering is installed, the next step is to integrate that metering with either a BAS or an energy information system. So in some campuses, they took the approach of simply integrating the metering with their automation system and using the automation system to trend that data. In other cases, they had energy information systems such as Itron or Ion that they were able to integrate in with and integrated the meter that way. Once that's done, the next step is to capture a baseline period of data with that interval utility information and to start to develop regression models and diagnostic models around that data to determine how the baseline performance is actually operating. Now, once the project has been implemented, it goes to more of a cyclical process to determine how the building is performing moving forward. So the same methodology is employed in the post-implementation state of the building to create a new model in the post-implementation state, still using the 15-minute interval data. But the idea is to overlay that model with actual utility data over time and use that comparison to identify anomalies so that you know whenever the actual utility consumption is deviating outside of the boundaries of what the expectation is from the model, and then you know you have a problem. So once you know you have that problem, the next step is to go investigate the root cause of whatever that anomaly was and make the appropriate repair. And then this process gets repeated at some predefined interval, be it monthly or quarterly or sometimes even weekly, depending on the system. So the example of this is for one of the projects that was implemented. The graph that you're seeing is just a 2-week overlay of actual data for electrical consumption and modeled predicted data. So the bar chart, the blue bars that are coming up are the actual energy consumption of the building over a 2-week span of time in the post-implementation state after monitoring-based commissioning was implemented and all the diagnostic and energy information systems were put in place. The red line with the red dots is what the model predicted. So this line gets generated through an engineering analysis of that 15-minute interval data that uses regressive techniques to identify ways to create a predictive model for how the energy should be or how the data should be performing over a period of time based on whatever the independent variables are, be it day of the week or occupancy time of day or outside air temperature. All of that happens in the background behind this graph, but the output that comes back to the user is a graph that looks like this, that identifies once an anomaly has been detected. And in this example, over a 5-day period of time, the operator went in on a Saturday and had overridden the schedule on an air handler, causing it to run outside of the time limits that it normally operates. And then that schedule was left in place and the schedule was left in hand and wasn't put back the way that it was before. So once that happened, the actual consumption started to exceed what the model predicted that it should on the red dots, and that was the identified anomaly. Once the operators identified that anomaly, they were able to go back and investigate what had happened and made the determination that a schedule had been overridden. Once the correction was made on Thursday, the data dropped back down below the model predicted values back to where the expected usage was. So this is just an example of using a manual analytical process to use the 15-minute interval utility data and energy information data to determine whether a building is performing at its optimal level or not after monitoring-based commissioning has been incorporated. So some of the advantages of this approach is that it enables us to quickly validate savings first and foremost. In a typical existing building commissioning project, sometimes validating the energy savings can be a little bit challenging without a lot of rigorous analysis. And a lot of times the savings are based around deemed savings or estimated savings from energy models, but not necessarily based around a formal MMB process. Using this monitoring-based commissioning approach with energy information systems enables us to validate those savings through an actual IPMVP compliant protocol method that can validate the energy savings. It's also an efficient way to call out anomalies within the data. It doesn't take a lot of engineering expertise to be able to look at a chart such as the one we were just looking at to be able to see whether or not the system is performing where you expect it to or not. Either it's above the line or it's below the line, and that tells you where you're at. However, the limitations are that it doesn't identify what the specific issues are. Any energy tracking approach with monitoring-based commissioning is not going to give you the intelligence to know, once you've identified an anomaly, what the root cause of that anomaly was. It doesn't tell you if it's a schedule issue or if it's a temperature set point that's been overridden or an economizer that's not functioning properly. So that additional investigation still has to be done by the facility staff. Another limitation is that this process takes time to do. There's a lot of manual analysis that happens behind the scenes to set these models up and make them work the way that we were just looking at. The other challenge is that sometimes the models require a periodic revision. If something happens in the building and the baseline changes, the model doesn't inherently have the intelligence to account for that change and to automatically adjust itself. So the analysis has to be redone and the model has to be recreated. It also makes minor anomalies sometimes difficult to detect. So sometimes if you have a typical project that might only save 5 or 6% energy savings in the building, a third of your measures could go out of whack and you would only see a 2% increase in energy consumption, and that would be difficult to detect using the interval energy data as opposed to using systems tracking information that actually looks at the detailed systems themselves. So one way to get around some of these limitations is to implement an advanced energy information system. These work effectively the same way, but the difference is that all of that analytical process and all of that manual data analysis that happened before is now automated. There's systems out there now that are intelligent enough that they have algorithms that are built in that can learn on the fly and continuously track a system's performance over time and use that historical information to predict how the system should perform moving forward, and use that information to then generate automated alerts that can go to emails or go to text message or any of those types of applications. So, So in this example, the dotted line is expected energy use that's based around how the system has historically performed and what the algorithm has determined the system should be running at based around the time of day, the outside air temperature, and a few other parameters. The solid line is the actual energy consumption, and what you can see is a specific point in time here right after 1 o'clock when an automated alert was sent to the user because the energy usage became excessive relative to what the expected value was. So once you get this alert, you know to go and do the additional investigation to determine what happened and what's going on that's driving my energy usage up. So this system is inherently intuitive. There's not a lot of complication to it. As you can see on this example, whether you're high or whether you're okay, it's very intuitive to use. It's very visual. It's not overly complicated, and it's very straightforward and very quick to monitor. That's one of the advantages of using energy tracking is that it is so time efficient and time effective and intuitive to use. And if you use the advanced energy information system, such as this example, it doesn't require a lot of manual process or analysis to set up. So with that being said, there's certainly a lot of further advantages that can be realized by taking it to the next level and monitoring actual system performance through monitoring-based commissioning. And with that, I'll kick it back over to Dave and let him give the next case study.
Okay, great. Thanks, Robert. So Robert just gave a good example of energy tracking. What I'm going to present is a case study of a systems tracking MBCX project. And we've been receiving a lot of great questions related to Robert's case study. What we're going to do is hold off until the Q&A period at the end in about 10 or 15 minutes in order to address those. But please keep typing your questions into the Q&A sidebar, and we'll try to get to those questions at the end. So let's see here. What we're looking at here is a systems tracking approach to monitoring-based commissioning. And this project is in Chicago. It is a large multi-tenant office building. It's about 1.3 million square feet and 65 stories. There we go. So the project team for this MBCX project, the building was owned by C.B. Richard Ellis. PECI was the program manager for this project, and the utility sponsor was ComEd, and the commissioning provider, the local commissioning provider in Chicago, was Sieben Energy Associates. So this project was actually a MBCX utility pilot project because ComEd, the sponsoring utility, they were really interested in seeing how, determining the effectiveness of MBCX. And so they did this pilot project along with another pilot project in Chicago in order to demonstrate the viability of MBCX. The goals for the project were to achieve 1 million kilowatt-hour savings from implementing low and no-cost operational type measures. Another goal is to maintain the persistence of those measures through monitoring and periodic reporting. And also, as I mentioned, another goal is to pilot the MBCX approach so that ComEd could determine whether or not to launch a larger scale program. Here's the project schedule and phases. The phases shown on the left side are very similar to EBCx, where you have the planning and setup at the start, at the first phase, and then a typical retro-commissioning that has investigation and implementation of measures. And then the final phase is the longest phase of the project. It lasted over a year, is the monitoring phase, where each month the reports would be developed showing the persistence of implemented measures as well as newly identified measures based on the data that was coming in from the system. So the project lasted over a year. In fact, it was about a year and a half long altogether. So the first step for this approach is to upgrade the building automation system. So with improved networking and communications, internet access of the BAS was added within the building's IT infrastructure. And this was crucial because it allowed the commissioning provider to access the system remotely in order to monitor system performance and facilitate gathering trend data. Another upgrade that was made was to improve some of the point monitoring in the system. With that, several critical monitoring points were added to the BAS, and these included power monitoring of some large HVAC equipment motors, and then also included incorporating energy data from the 5 building electrical meters so that the meters could be accessed through the BAS. So C.B. Richard Ellis spent approximately $50,000 on these metering upgrades. And remember, this is a large building, so there was some significant cost to it, but they paid back rather quickly, as we'll see in a bit. And all of these costs, their cost was reimbursed by ComEd as part of the pilot program incentive structure. So the BAS was used during the monitoring phase. The upgrades were used during the monitoring phase in order to monitor the performance via analysis of the data that was coming in. And there was really three main focuses for monitoring performance. One was to determine the persistence of implemented measures. So the commissioning provider would look at key performance metrics related to those measures and determine whether they were persisting or not, and then report out the following month. Next step was to deepen the savings from measures already implemented. So if a measure was implemented that was basically a toe in the water, just a small little change to the system performance, perhaps it could go. The change could go deeper for more deeper savings. And then the third reason for monitoring performance was to identify new measures that were not already identified during the initial commissioning effort. And for Chicago, some seasonality effects were included in this because maybe the new measures were ones that were wintertime related measures if their commissioning effort initially was only during the summertime. So seasonality played into it a little bit as well. So the process was really streamlined compared to most commissioning projects since the commissioning provider was able to access the BAS remotely. And then over time, they became very familiar with the building automation system. So for the project savings, initially 6 measures were implemented as part of the initial existing building commissioning effort, resulting in 366,000 kilowatt hours. And then during the monitoring phase, 3 of those initial measures expanded by going deeper with the control algorithms, resulting in deeper savings. That way. And then during the monitoring phase, 3 additional measures were identified and implemented, resulting in 425,000 kilowatt hour savings. So it's interesting to note that the initial EBCx effort resulted in the lower box of savings, whereas the monitoring phase really is what produced the bulk of the savings in this particular project. I don't think that this can be extrapolated to say that this will be the way that all MBCX projects will go. But on this particular one, the monitoring phase really helped boost the project savings. In fact, it exceeded the project goal of 1 million kilowatt-hour savings. And I believe that the savings for the project, which is around 1.36 million kilowatt-hours, was around 4 or 5% of the whole building usage. So the owner's implementation cost was $30,000, around $30,000 for the project, and the estimated annual cost savings is over $100,000. So very, very quick payback on the measures that were implemented, which were HVAC-related operational measures that were implemented for this project. So in addition to tracking that system-level performance at the building automation system, overall energy performance was monitored. And as shown in the chart on this slide, the Energy Star score increased throughout the project. So for projects such as this that use a systems-level monitoring approach with energy savings as the goal, monitoring energy usage at a high level, such as through Energy Star's Portfolio Manager, can help show that the project goals are being met. So some successes for the project. The project demonstrated the value of MBCX for ComEd. And it demonstrated the value so much so that the customer, CB Richard Ellis, decided to continue on with the monitoring-based commissioning program after the utility pilot project was finished. So CB Richard Ellis hired the local commissioning firm to continue monitoring the performance of their buildings because they saw so much value with the project. And also the project exceeded the savings goals, which is always nice. Some challenges with the project. At the start there were many BAS upgrades that were identified. Basically, there was a wish list that was developed, and the building owner was not able to implement all of those because of the cost. So it was really important to prioritize which BAS upgrades were most important in order to achieve the project goals. Another challenge was that once the upgrades were in place, the commissioning provider found that there was a flood of BAS data coming in. So kind of be careful what you wish for, because there it comes. So what they did was they invested in the commissioning provider ended up investing in a fault detection and diagnostic software system to make the process more manageable of analyzing the trend data. It took a long time to set up that FDD system, though, so much so that they weren't able to use it on this project, but they plan on using it for future MBCX projects. And another challenge was integrating the utility meters into the BAS. That just took longer than expected. So the lesson learned there was to do it really early in the project, first thing, because even though this was a system tracking project that used the BAS, the energy savings and the utility wanted to see the results at the meter, and integrating that into the BAS took some time. The cost for this project, it was about 20 cents per kilowatt hour for the utility cost for the pilot. So that's what the utility ended up paying. And we think that that could probably be reduced to around 16 cents per kilowatt hour saved for a larger scale program. And the thing to keep in mind here with MBCX is that the effective useful lives are going to be longer. We mentioned that earlier, that on average it's 8 years. Well, this project they're expected to last longer, so that plays a role in cost effectiveness as well. So advantages with using the BAS, the operating staff is already familiar with it, so you're not introducing a new system to the building operators for them to have to learn. They didn't have to add a new system. They just basically worked with what they have. Although some building owners may want to invest in a software system. It really depends on the customer, and it depends on the goals of the project. But for this one, it worked out really well to just beef up the existing BAS a little bit. So some limitations is that this process requires manual analysis of a lot of data. It can be time intensive. And what could be done is you could have a third party do this, such as somebody not associated with the building, and that's the arrangement that the building has right now, is they've hired this engineering firm to analyze the data. Or you could use fault detection and diagnostic software to help streamline that analysis. And then the other limitation is that you may need to upgrade some aspects of the BAS. The BAS, or Building Automation Systems, their primary design is to control systems. It's not necessarily to monitor or to gather trend data or to report out. So they may need some upgrades if that functionality is not already in the BAS that's in a particular building. So those are just two case studies that Robert and I have presented, and neither of us is aligning or promoting ourselves with either of those approaches. We both feel that there's value with energy tracking and system tracking. It just depends on the goals of the owner and the project and the program. So those are just two examples. There's more case studies at the California Commissioning Collaborative, and the four that are shown on this screen are just examples of what's shown on that website. And we'll include a link to those case studies and follow-up communications after this webinar.
It's time for live polling question number 3. You'll see the question in front of you here. What are your top challenges to implementing or participating in MBCX projects? And as the answer to that, instead of pausing here, I'll hand it back to Dave for some closing thoughts, and then we'll look at your responses to this during the Q&A session.
Okay, thanks, Dan. So this poll will stay up for you for attendees as we're going along here. So just take a look there, select all the answers that apply, and then we'll get into the Q&A in a little bit. While you're doing that, we'll go with some closing thoughts here on MBCX. So which approach is right for you being a customer or you being a utility? There's a variety of different audiences for MBCX as well. The first thing that I would recommend is to select a tool that will help meet your specific goals. So depending on your goals, you may choose to use an energy tracking tool, you might use a system tracking tool, or you might even use a combination of the two, depending on what your goals are for MBCX. I'd also recommend selecting a tool that will be used. So compare the level of analysis that's required with these various tools with the capabilities and availability of the in-house staff. There's going to be more operating staff buy-in on the project if they're going to use the tool after the utility MBCX project finishes, if it is a utility project. As I mentioned before, it's really important to include the operating staff on the MBCX team, as they're the ones that are really knowledgeable about the building systems and interested in maintaining them at peak performance. And then finally, you can use additional resources to get started. As we saw in an earlier poll, many people attending the call right now are just learning about MBCX and hearing what it's all about. There's other various resources to help you get started. You can talk to commissioning providers or commissioning authorities. They should know about these aspects, these types of monitoring systems. You can talk with software tool vendors. There's a variety of them out there nowadays. And you can also talk to energy consultants that should know. And also you can take a look at the Building Performance Tracking Handbook. Again, that will be sent to all the webinar attendees after the webinar to get an idea of what's really involved with the type of tool to select, as well as what's involved with the overall process. And PECI is looking at and working with a lot of different monitoring methods right now, because this is a really a new industry, and it's a really exciting industry. And we're looking at it for both utilities as well as individual building owners. So PECI can help navigate those waters as well.
Okay, as we wrap up here, we'll jump into the Q&A portion of our discussion. And one of our first questions is for you, Dave. In your case study, you mentioned that some of the measures expanded during the monitoring period. That is, they were identified and implemented during RCX, and then they grew somehow during monitoring. what were those measures, and how did they grow?
Right. The two main, I mentioned there were three measures that expanded. The two main measures, the ones that were responsible for the bulk of the savings, expansion of the savings, are duct static pressure reduction and air handler scheduling. For the duct static pressure measure, initially it was just a slight reduction in the pressure, but during the monitoring period, the building operators and the commissioning provider determined that they could actually implement a duct static pressure reset strategy that really tunes the performance of the system to what's needed. So more of an active type of control. And then air handler scheduling, initially they had tightened up the schedule just a little bit, but during the monitoring phase, they implemented a optimum start sequence for the air handlers, and that really deepened the savings quite a bit as well.
So we had another question, and this one will be for you, Robert. During your presentation, you talked about a $1 to $3 cost for energy in your pilot's experience. Is that for energy tracking only? Does it include more than that? What's included in that cost?
That cost was the full and complete cost of the project, including implementation of the recommendations and the energy tracking system. So that cost included the monitoring-based commissioning service from the engineering provider, which was us in this case, as well as the cost of metering. So in some cases, the building only had totalizing meters, and in some cases, no meters at all. So a big chunk of the cost was upgrading the metering and installing interval data metering for electricity and natural gas and chill water and steam. And then it also included the cost for implementing the measures, which in all cases included controls programming, but in some cases included some other repairs such as VFD repair and replacement, and some mechanical repair and replacement work as well, and in some cases even rebalancing the building. So that was the full and complete cost of the project.
Okay.
And I guess and part of the reason for that range, again, is because the metering component really does contribute a fair amount, especially if the building is a smaller building. The metering can contribute a fair chunk of that cost, and if the building already has some of that metering in place, that keeps the cost on the lower end, and that was really the biggest variable in that number.
Okay, thanks, Robert. The next question I'll pitch to Dave. The question is, are you aware of any financial incentives that exist for MBCX, and how are they generally determined? Are they use deemed or customized savings?
Yes, so I am aware of financial incentives. As Robert mentioned, there are incentives through the MBCX program in California, and the ComEd pilot, I think they've also started their own MBCX program. So I would say that the first step would be to contact your local utility to see if they have incentives for monitoring-based commissioning. And it's been my experience that they're generally determined based on a customized basis. In terms of the incentives, for instance, the investigation incentive and the monitoring upgrade incentive, that might be more of a deemed basis, such as per square foot or per historic energy use or something like that. But on individual measures implemented, it's more of a custom basis. Robert, did you want to speak anything more to financial incentives for MBCX?
I would just add that in instances in California where energy tracking is the primary approach for monitoring-based commissioning, the incentive is based around a certain dollar amount per kilowatt hour in therm saved, and because the energy tracking system is used, they're using that to do a formal M&V process to know what the actual validated savings were using IPMVP protocols.
Okay, Robert, I think this next one came up during your presentation. I think it's appropriate to ask you about how, on your projects, you're able to integrate into the building's energy data or building automation system.
In most of the cases that we worked with, the campus already had a system in place, and in one case it was Itron, in another case it was Ion, where they already had that on the campus. They simply hadn't integrated all of the meters in all the buildings onto it yet. So there was already a parallel effort underway to do that. So there wasn't a lot of involvement in our part on integrating that. But I know the way that they did that is they worked directly with those service providers that own and service those proprietary systems.
Yeah, thanks, Robert. I'm just going to take a quick look back at the polling results, and I'm not sure if folks can see this on their screen, but we had kind of mixed responses to the different types of challenges folks are facing. The number one with 30% was difficulty translating the value proposition to the potential benefits for a customer. A lot of folks look like they're just kind of learning about the process as well. There's a little bit of uncertainty about ROI, so and that makes sense, as you know, the costs can vary pretty widely depending on the approach you take. Even the type of building you're looking at, the example from Chicago is a 1 million square foot building, so that you're able to kind of scale the costs across a very large energy consumer. Whereas if you're looking at smaller buildings, that cost could, that scale could be much different. Your costs could look a lot different. So these are some of the common challenges, and a lot of that has to do with the approach you select. And I think Dave and Robert did speak a little bit to that.
Yeah, and I'll just add that one other thing that we'll include in the follow-up communications to the webinar is a report that LBNL, or Lawrence Berkeley National Labs, published on monitoring-based commissioning that also gives a range of costs and savings that were very similar to what Robert had mentioned in his presentation. It can also help attendees get a better idea of what's involved, and it can even vary by the scope of the type of building. You could have small laboratory buildings that have a very high per square foot cost, but maybe high per square foot savings as well. So it depends on the building type, but we'll include that report for webinar attendees to take a look at.
We have another question here around predictive modeling and who provides it. So I think it's asking about who are the vendors who maybe provide some of the software that can help with that, or if it's kind of in-house developed. And then also, it's more specific around, does it come from the utility or service providers, and how does someone from a utility understand who has those resources?
Yeah, I'll start, and then maybe Robert can add to it. For Robert's example, the predictive model was something that Eaton developed in-house. Basically, it was more of a manual analysis of the energy data to develop the predictive model based on such factors as outside air temperature, time of day, day of week, that sort of thing. But there are service providers. There are companies that provide advanced energy information systems. There's a variety of them. I think that we have some of them listed in the Building Energy Performance Tracking Handbook, so you can take a look at it there, which we'll send out. And so I would say take a look at that handbook as a first step to learn about service providers. But new ones come up every week or every couple weeks. It's a really new industry, and so I would just encourage you to keep your ear towards that. And I also, maybe one thing we could send out to webinar attendees is that LBNL published a study of advanced energy information systems and the current crop of providers as of mid 2011, I think it was. So that might be helpful to webinar attendees to see who provides these systems, these software overlays right now.
Yeah, the only thing I would add to that is just to emphasize the point that in the case study examples and in a lot of the projects we've worked in, the metrics methodology was used. If you go back to the slide, the middle tier of the energy tracking methodologies, where it wasn't automated, it was a manual process that had to be done through engineering analysis. I'm a big proponent of utilizing advanced energy information systems, primarily because they are adaptable in real time and don't require all of that analytical effort to be able to set up. And so I definitely would just kind of underscore and emphasize what Dave mentioned, to look into some of the providers that offer some of those specific packages and technologies that they've developed. Certainly because it is a new industry, I would also caution a little bit of buyer beware, just because there's a lot of up-and-comers, if you will, that are developing tools and techniques for it. So you want to make sure you get a good one. But that being said, I'm a big proponent of that methodology over and above the manual process that was outlined in the case study.
Okay, we got time for one last question. The question is around the ability of the energy tracking and system tracking approaches to complement each other, and do we know of any specific examples where it's kind of both approaches are taken?
Yeah, I think it is a good idea to combine both. Again, if it's part of the project goals. So the case study that I presented was system tracking, where they beefed up the BAS, the Building Automation System, to track performance. But also they were looking at Energy Star, and that's a method of tracking. That's a method of energy tracking, is to do that. And so we do see that a lot where people use both. I know of another instance where the energy manager was using an EIS, or Energy Information System, to identify anomalies. And as soon as an anomaly was detected, they would communicate with the building operators, and then the operators would use the Building Automation System's trending capability to find out the source of those anomalies. So we do see energy tracking and system tracking combined as part of the same MBCX effort.
Okay, and that's about all the time we have for questions. Karen will just wrap up here, and thanks to you all for joining.
Yeah, thank you, Dan, and thank you to Dave and Robert as well. Just a couple of last notes. When you close out of the webinar, you're going to be redirected to a short survey. Please take a moment to provide feedback on this webinar, and also to let us know your interest in other webinar topics that we're planning. And then, as we mentioned, we will be sending out a follow-up email containing monitoring-based commissioning resources and a link to the recorded version of this webinar if you want to share it with your colleagues. Look for more webinars on energy efficiency topics throughout the year. Thanks for attending Unlocking the Potential of Monitoring-Based Commissioning, and have a great afternoon.